In this video, we'll be covering the free responses from Chapter 6 in your review packet. We will see how long this takes me when I talk through it. Hopefully I can put more than one in each video, but we'll see how it's divided up. But we're going to start with 2005B, number 2. So it says, for an upcoming concert, each customer may purchase up to 3 child tickets and 3 adult tickets. Let C be the number of child tickets purchased by a single customer. Probability distribution of the number of child tickets purchased by a single customer is given in the table below. And so part A asks you to compute the mean and standard deviation of your random variable C. So, one sec, I would suggest using a calculator on this question. So I'm getting my calculator ready. I want you to think about I want y'all to really grasp the idea of a random variable. Alright, C is a random variable because it could, and it's discrete, because it could take on different values. It could either take on 0, 1, 2, or 3. And then they give you the probability for each of those values. So if you were going to do mean and standard deviation by hand for a discrete random variable, you would use this formula for mean. You take each observation and multiply it by its probability and add them all up. That one's pretty easy to do by hand. Now this one you can do by hand, but it's a lot more work and takes more time. So what I would suggest is using your calculator, and you go to, actually you're going to need to go to a list and spreadsheet, and I would label my first X, and this should be P because it's probabilities, and you type in your data, so 0, 1, 2, 3, and then the probability for each one. And then you go over to the next equals, and we're going to type menu, statistics, stat calculations, and this is still one variable because you only have one variable. The other list was a probability. Keep your number of list 1. Make your x1 list X, or whatever you labeled it. Your frequency list is your probability, P. Keep everything else, go to OK, and there you have your mean, and if you scroll down, your standard deviation. So if you notice in this case, the standard deviation is 1 and the mean is 1. So we're going to write that out for A. We're going to say the mean of C is 1 and the standard deviation of C is 1 as well. You shouldn't have to show any work for that. I'll have to double check, but if you did it in the calculator, I don't know how else you would show work. Maybe you could show out like just a couple from the formula. If you're worried about getting points, you could do the mean. If you did it by hand, you would do 0 times 0.4 plus 1 times 0.3, and then you could just put dot dot dot, and the standard deviation, if we were going to use the formula, you would do the square root. You would take the first observation, which is 0, subtract your mean, which is 1, squared, times the probability for that observation, which is 0.4, plus, and you could do one more, the next observation was 1, minus the mean, which is 1, squared, times its probability, which is 0.3, and then you could just put dot dot dot, and those two things should equal 1. Okay, so then for part B, it says suppose the mean and standard deviation of adult tickets purchased is 2 and 1.2. So I'm going to go and write this down. The mean of adults is 2, and the standard deviation for adults is 1.2. Assume that the number of child tickets and adult tickets are independent random variables. Compute the mean and standard deviation for the total number of tickets, adults and children together. So what I would do is you're combining your variables, right? I would define make a new variable. I'm going to say T for total. And what are you doing to get the total? You're going to take the amount of children tickets plus the amount of adult tickets. So you're adding your variables together. So then that means the mean of T, since you're adding two variables together, is going to be the mean of C plus the mean of A. So we can go ahead and get that value. Mean of C is 1, the mean of A is 2, so the mean for your total is 3. Now for standard deviation, if you remember, the t. If you're adding two variables together, where did I put my, did I already put it up? Probably. You can only add the variances, right? So if you're going to do standard deviation, you need to square root it. So you can go straight to this step. You don't have to show this and then square root, but if it helps you to do this and then square root, you can. Up to you, because it just asks for standard deviation, so you don't need to show the variance. But if it helps you to do that, you can. But I'm going to go ahead and say the standard deviation equals the square root of the variance for C plus the variance for A. So you just plug this in. The standard deviation for C was 1, and you square that, plus the standard deviation for A was 1.2, and you square that. And you type that in your calculator, and that makes it, do I have it? It seems off. I have 33.54. Oh, no, that's why it's off, because I was looking at the wrong one. It is 1.562. That makes a lot more sense. 35. That makes 0 sense. Okay, so that would be it for that one. So then C says, suppose each child ticket costs $15 and each adult ticket costs $25. Compute the mean and standard deviation for the total amount spent per purchase. So now what you're doing is you're multiplying your data by a constant. So I'm going to create a new variable. We already used total, and I already used A, so I can't do for amount. Maybe I'll do M, since now I'm talking about money. It doesn't really matter. But now the total amount, the money spent, would be, each child ticket is 15, so 15 times each child ticket, plus each adult ticket is 25. So 25 times however many adult tickets is going to give you the total amount spent on a given day. So now again, we want the mean of that variable and the standard deviation. So for mean, you just do exactly what you think. 15 times the mean of C plus 25 times the mean of A. You cannot use that total because C and A are being multiplied by different constants. So 15 times 1 plus 25 times 2 should be 15 plus 50. So it should be 65. So now for standard deviation of the total spent, the money, again you would have to square root, and now when you're multiplying a variable by a constant, that needs to go with the standard deviation. So you know what, maybe it would be better in this case to show you the way you could show it starting from variance. So the variance of M would equal 15 times the variance of C plus 25 times the variance of A. So if we're going to do it this way, oh, you know what, I still though need to make sure you're multiplying the standard deviation by 15 first and then you're squaring it. Same thing here. If you're multiplying by a constant, you do it before you square it. Which I know doesn't seem to follow order of operations, that's why you got to put the parentheses there. And so then we could plug in our numbers. So it would be 15 times the standard deviation of C is 1, plus 25 times the standard deviation of A is 1.2. And this would be 1,125. So that is the variance of the total spent. So to get standard deviation, you have to square root it. So you could have originally just put that square root over here like we did here and just get standard deviation, either one. And if you square root that, that's where I was getting 33.54. So just make sure if you're multiplying by a constant, you are multiplying the standard deviation by that constant. You have to also square it if you're going to get variance. That is what I was trying to talk about here when we were reviewing, right? You're multiplying the variance by your constant squared. And I think that covers everything for that one. Let's go ahead and do the next one in this video. So the next one is 2013. And number 3, it says each full carton of grade A eggs consists of one randomly selected empty cardboard container and 12 eggs. The weight of such full cartons are approximately normal, with a mean of 840 and a standard deviation of 7.9. Okay, so I know it doesn't ask you to do this, and I'm kind of like going ahead, but it's going to kind of help us later. If I go ahead and make this a random variable, right? So I know the total weight is equivalent to one cardboard box, which I can make that C, or the cardboard container, plus 12 randomly selected eggs. So be careful. Theoretically, what you're doing is you're taking, let's say X represents, because X is going to be the weight of a single randomly selected egg when I get down here. So it's 12 of those. You add them. I would be very careful about writing 12 times X first, because you're not multiplying by a constant of 12. It's not 12 times one weight. It's 12 different eggs that all are going to weigh different things. So you can't technically just say 12 times X. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I know it seems extra, but there's a point to what I'm getting at. It's going to change something later. Because technically this is the weight of the first egg, the second egg, the third egg, and those aren't all going to be the same weight. So you cannot just multiply by 12. Now when we're doing the math we will be, but conceptually you need to understand that that is what's happening. Okay, so all that to say, now let's get into A. So it says, what's the oh, you know what? Hold on, let's also write down what they told us. So the mean of that full carton of the total, the mean of T is 840, and the standard deviation of T is 7.9. So then it says, what's the probability of a randomly selected full carton, which is what we're talking about, T, will weigh more than 850? So if you think about this, this is a continuous random variable because it's grams, it's decimals, there's not going to be gaps. It could be 7.9, 7.99, and so on and so forth. So because it's because it's continuous, we can use a normal continuous random variable. You use normal approximations. So it is going to be normal with a mean of 840 and a standard deviation of 7.9. So just make sure you write that down. And then we're saying, what's the probability of finding a package that will weigh more than 850? So that would be 850, and you shade greater than. So that probability is going to be normal CDF with a lower bound equals to 850, an upper bound of infinity, 9E999 in the calculator. The mean is 840, and the standard deviation is 7.9. If you go to your calculator and you type that in, see, just in case we need a review, add calculator, menu, statistics, distributions, CDF is 2, and you type in that info. Mean is 840, and its probability is 0.10. You can keep that 2 or round it up to 3 because of the 7. And that answers that question. I don't know why I put 2 equal signs. I guess I forgot I already put one. Okay. So then part B says the weights of the empty cardboard containers have a mean of 20 grams and a standard deviation of 1.7. It's reasonable to assume independence between the weights of the cardboard containers and the weights of all the eggs. It's also reasonable to assume independence among the weights of the 12 eggs that are randomly selected to fill a carton. So then it says let the random variable x be the weight of a single randomly selected egg, which we did that. What's the mean of x and the standard deviation of x, which is your weight of a 1 egg. So let's talk about what they gave you. The mean and standard deviation of the cardboard container of C, right? So we know, I'm going to rewrite this information so I have it all together. The mean of the total was 840. Standard deviation of the total was 7.9. Now we know the mean of the cardboard container, C, was 20. And the standard deviation of the cardboard container was 1.7. Now we are going to be solving for the mean of x and the standard deviation of x. So we're going to use this setup. So we know the mean is normally the easy one. So we know the mean of t is going to equal the mean of c plus what? The mean of x plus the mean of x, because now all these could take on different values, but they're going to have the same mean. They come from the same distribution. So you could think about writing it out 12 times, but now because that's going to be the same value, we could rewrite it as the mean of t equals the mean of c plus 12 times the mean of x. And now we plug in our stuff and solve. So 7.9 equals, not 7.9, we're doing mean, 840 equals 20 plus 12 times the mean of x. So then we solve this. Subtract 20. 820 equals 12 times the mean of x divided by the 12. And 800 divided by 12, 820 divided by 12 should be 68.33. So your mean of x is 68.33, and that would be in grams. I should be putting units. Okay, so now let's think about this in terms of standard deviation. So remember, we can't add standard deviation, so let's first write it out in terms of variance, the same way we did it here. Let me do a different color so it doesn't run together. So we know the variance of t will equal the variance of c plus the variance of x 12 times, right? You're adding up that variance 12 times. So I want you to keep in mind that you are not multiplying by a constant. So remember, if you watched the other video, when we multiplied by a constant, you had to square that constant when you were doing your math. But here, you're just adding that variance up 12 times, so it's not the same. The way that would look would just be 12 times that variance. So you are not squaring the 12. You're just adding up that variance 12 times. There's a difference. So if you would have wrote this as 12 times x, that would have looked like a constant, and you should have put the 12 in parentheses and squared the 12. So just be careful about the difference. So now we just plug in our stuff. Standard deviation of t is 7.9 squared equals the standard deviation of c, 1.7 squared, plus 12 times the standard deviation of x squared. So we can do 7.9 squared minus 1.7 squared equals 12 times standard deviation squared. And I don't have the actual math. You could actually get this, or you could just divide by the 12. Notice I didn't square the 12. And if you get this answer in your calculator, that should be, where is it? 4.96 equals the variance of x. So if we want standard deviation, we just square root it. And that gives you 2.23 equals the standard deviation of x, which would also be in grams. So hopefully that kind of helped. That's really good practice on combining random variables. I think I'm going to do the next video in a different, or the next free response in a different video.